Good evening, all of you. I welcome you, all the participants, for our ATAL online 6-day faculty development program, empowering the next generation of entrepreneurs with deep learning and cloud-powered AI technologies. We successfully completed our today's sessions, and we completed almost 4 sessions. Now we are entering into the third day. We are grateful to the speakers, and we are so delighted to have all of you. Today we have 2 special sessions, that is session 5 and session 6. Here in the session 5, we are going to discuss about cloud computing for AI-driven startups. And in the next session, optimizing AI workloads on the cloud. Now the session discusses about how cloud infrastructure supports AI-powered startups and scalable solutions. The session expert, Dr. Suresh Merugu. Yesterday, I introduced Sir profile, very excellent profile. He had his PhD from IIT Roorkee, and then his publications and expertise in various areas that we have never known, sub-pixel classification, something like that. Anyway, we had wonderful speakers with us. We are so grateful for them. Now let us start our session of cloud computing for AI-driven startups. Now I welcome Dr. Suresh Merugu sir to start the session. I hand over the time to Suresh Merugu sir. Sir.
Yeah, thank you, sir. Thank you so much. Good evening, everyone. Yeah, thank you. Can I share my screen?
Yes, sir. Yes, sir. You can share.
Yes. Is my screen is visible, sir?
Yes, sir. Visible, sir.
Yeah. Thank you, sir. Thank you so much. Very good evening to one and all, ladies and gentlemen. Thank you. Thank you for being here today again. So I am excited to talk about the significant impact of cloud computing on AI-driven startups. So this is the topic today, and the subtitle, as mentioned here, understanding how cloud infrastructure supports AI-powered startups and scalable solutions. This is the actual title. So here I will take you with a basic introduction, and then how exactly the startups already existing, how they have done, and what to be taken care and not to be done, do's and don'ts, these things we are going to do. So coming to here, so cloud computing refers to delivering computing, like computing services over the internet, allowing startups to access powerful resources without the heavy upfront investments, right? Either in terms of hardware or otherwise in terms of infrastructure. So especially when we talk about the startups, so cloud computing is also one of the most, rather I can say it's a crucial for 3 main reasons, especially what? So for the first one, if I say it offers it means cost efficiency. Especially for the first point, we can say that is cost efficiency. It's one of the most important point. Because enabling them to reduce their operating cost and whatever they are going to start. Second, it provides the scalability, especially scalability, allowing startup to quickly adjust their resources based on demand. That is the most important, another scalability. So there they have to adjust with respect to the source of resources, whatever they have, and that could be as and when they require on the demand. Like that. And finally, it lets entrepreneurs focus on their core business, dedicating their energies to product innovation rather than IT management. So like that, they can concentrate and they can work because while starting the deal, what they have, based on that, they can come up and they can work, especially for their baby product, like that. Either it will be in the form of product or in terms of something or the application, like that. So when we talk about this, so therefore there are different cloud models are available, like public, private, hybrid, and otherwise multi-cloud, like this. So we'll see each and every step one by one, and I'll give you just starting with basic introduction and then some applications also, and how exactly the scalability. And then after that, the best case studies I have shown, I'm going to show. And along with the case studies, how exactly the means best practices to be followed while you are going to start a startup, and how you are better way you are going to use the cloud. Okay, so coming to here. So here, introduction. So when we talk about this cloud computing, so the definition here, we can say cloud computing like delivers computing services over the internet, and including servers, storage, databases, networking, software analytics, and other intelligence. Based on that, we are going to use it. So here, when we are saying this, but there should be very important key features we have to keep in our mind. Otherwise, we have to learn and aware while working with this. So what are they? So here, especially the key features I've taken this as a total 5. The first one is on-demand self-service. That is the first one. And coming to the second one is about the broad network access. That is one of the most important point when we talk about the cloud computing, whenever you're working with respect to this. And the next one is the resource pooling. So how exactly the resource pooling you're going to do, and then rapid elasticity, right? And then measured services. So like these are the main key features which you have to concentrate while you are going to working with the. So here, when we talk about the on-demand self-services, like resources can be provisioned automatically without any human intervention. Like that, we have to think. Right. Second one is about the broad, like services can access over the internet via multiple devices, like through Internet of Things, like that you can from another just like that, how remotely you can access. And with respect to the, like we can call it as yesterday talk, I told you, like automation home, how exactly the smart automation can be workable and how it can be used in effective way. But also we have to. So when talking resources, like resources are pooled to serve multiple, because you are working on multiple domains. So multiple consumers, especially efficiently also. So like this, when you're tracking, so you have to be resource pooling is very important when you're working with respect to the consumers. Next, rapid elasticity. So this we can say that the resources can be scaled elastically based on demand, because the demand it will be depends on, correct or not. So as in when the demand comes, we have to be in the should be in that flexible way. So like that, scale elasticity is also very important when we are working with cloud. Next, measured services, like resource usage in monitored and reported. Every time we have to measure ourselves, and we have to test with the help of like we can call it as a go up template I can use to call. So GOA is nothing but goals, objectives, and actions. So with respect to our short-term goal or long-term goal, whatever are there, and with respect to those goals, what are our smart objectives? How we are going to measure and how we are going to doing action. So like this, that's why I call it as GOA template. Goals, have objectives and actions. So like this, you have to think whatever, because we have to test ourselves every time. So like this, you have to make based on our goals. Like that, we have to work. Right. So coming to here, cloud computing. If you see this picture here, this shows about the just brief overview about the cloud computing. Right. So there will be different gadgets will be connected to this, and there will be application like application monitoring, content collaboration, like that. And there indirectly there should be some cloud, and at the same time there through servers also we can work. So like this is the cloud. So in this cloud, we can also work like application platform with the various platforms can be used, and various infrastructures also to be taken, and which to be used and which not to be used. Like this, we have to be very keen when you're working. So this slide just shows you about the application platform and infrastructure, and with respect to cloud and various servers and other gadgets, how you are going to interlink. So this is about the basic introduction to this, and how this exactly the process, like extracting the information from the cloud. So this slide just shows about the data flow diagram. Like a data flow, that means the journey of the information through a particular system or a particular model, or you are working with the smart automation, or otherwise some whatever you are working. So this is the just simple symbolic representation, and here all things are matters here, like the generative AI also comes into picture, because when you're working with a model, how effectively it is working or processing, that also can be taken, because nowadays each and every one of us are in a stage that we need everything to be on our fingertips, correct or not? And that to be in fraction of seconds. So because many of people have because they don't have the time to wait, they want everything on. So we have to compete as in, because we are in a competitive world, so we have to think in that way, right? So in those cases, each and everything should be work done in a fraction of seconds. So that's the reason. So how we have to make it more smart, how we can do that we can. So it is just only the data flow diagram, how exactly it works. And when we come to this current startups, so here that is about the basic introduction. I'll come to the models also one by one step. And now, because we are working with respect to cloud computing with respect to AI driven through startups. So what are the startups here? The present, current, and well-established startups here. I'm giving you few like Redbus.in, InMobi. Like these are the major. Already you might have heard, and you directly or indirectly people are using it. Correct or not? So these are the major achieved startups and with a good wealth and good GDP they are maintaining, right? Like Dropbox, Redbus, Netflix, right? Khan Academy also very good one. Pinterest, right? Mobstack, Solid, next Airbnb. These are right. So each and every startup is having its own unique importance, right or not? So like that, and one more important is not only just startup; they are already cloud enabled through Gen AI. So they are maintaining it. Like this, they are using. So these are the few only I highlighted here in this slide. So the coming to the why cloud first startups. That is most important. Why we need cloud. Okay, so like this we'll see. So when we come up with this, then I have given with a few different questions in format, or otherwise in the form of like target, like that we can also see. Like start small means whenever you want to start a startup, you can start with a small start, like a no capex and pay as you go. So like means it should not be a like a huge investment, and you had start with small, like that. You can start and then scale fast. Zero users to million in hours. Million in hours. That means zero users to million in hours. Like that, how we can do scale, how we can fast scale, how we can do that scalability, how we can increase it. Like that, we have to think, right? Flexibility, and at the same time, the ties of infrastructure and programmability, how we are going to make use of them. And we are talking in this, right? So in these cases, why this cloud is important, right? And think big. So whatever you're working, you have to think big. So always we know from our childhood onwards we are using, right? Always we have to think big, because at least we think big, we can achieve something, right? So that is the main motto. What we should have, correct? So global within minutes. Like that, you have to think and you have to work. In these cases, we have this why we have this cloud computing. So why? Next, another one is focus. So do what you do best instead of system admin, and what you have admin tasks. What instead of taking just simple system admin tasks, you can also think what best you can work with respect to this. Like that, the focus should also be in line with your aim, what you are going to do. If you have that defined focus, then you will be in that line. So like that, in all these cases, cloud is very much important when we are working with this, correct? And importance of this cloud computing, how its importance is. So mainly here, first I can highlight that is about cost efficiency. So here, when you're using this cost efficient, because it reduces the need for expensive hardware and software licenses, correct? So these things we have to we have to be in keen while working with this. Because startup means it's like everyone come up with an idea, right? So with this small idea, how you are going to make big things. So in those cases, initially you may not be having some investments, correct or not? So some may not be having, or some we need no need. Many people they think no need to invest initially itself, correct? Because they won't predict, right? If they have that and they have the confidence, then they can come up and they can. So that is the most important point here, cost efficiency. So pay only for what you use with flexible billing. So like that, on the go, whatever you require, what on the daily basis, on the team basis or on the activity basis, you can do that. Okay. So next one is scalability. Right. So enable rapid scaling of resources based on business growth. So when you are coming with a simple idea, how it's going to be effective. So how you are going to make it as scalable means how you are going to increase it. So in that cases, you have to follow some basic business. So you have to work with respect to the resources which are required to that. And you should be flexible to increase computing power during these big loads, whatever you have. Like that, you have to plan. That's why we call it smart objectives to be come into picture when you want to do like this. And here, focus on core business. So what exactly? You have to be focused. That means you should be focused exactly on what is your uniqueness, your idea based on that. Then you have to do. So allow startups to focus on product development and innovation without worrying about IT. These are the most important points. Okay? So this is why it is important to have a startups, right? And next, the last point here in this that I can say that is about access to advanced technologies like AI, machine learning, big data analytics capability. These all are the because we have all these things. So how we can use of with them, okay, and smart way. So like that, you have to think and you can access the advanced technologies of area or your with respect to your idea. Clear? So this is about the importance. And coming to here, this is the especially about the cost analysis. So how cost analysis of cloud versus on-premises, on cloud, and as well as the on-premises. So when we see here, when we talk about the on-premises, this is about the on-premises and this is about the cloud-based. So here, always on-premises means you should have some hardware cost, you should have some backup cost, right? Some at least we have to maintain, right? And there should be a maintenance cost to maintain all this. So this is about the on-premises, right? If we see on cloud, so especially when it is coming when it comes to cloud, so it should be low hardware cost, so they're not required, right? And backup and recovery cost only that also will be very less, and then security compliances. So these are the main important. Just like I want to give you the basic on-premises and as well as the cloud, how exactly solutions works and how different they are. Correct? So like this, that is the reason the title of the talk, today's talk also highlight about that. Why cloud computing with along with the AI-driven startup, why it has to be. So in that way, if you think, so like this cloud is very cost efficient, effective, right? Cost efficient. That's the reason. Okay, go ahead. And cloud models. So what are the cloud models we are available? Okay. So here I'm covering you as I told you, public, private, and some multi-hybrid or otherwise a multi-model. Correct. So here we have public cloud, like we have already, right? Many of you might be using also, like services offered by third-party provider, like public internet, like AWS, Amazon Web Services, Azure, Google Cloud. Correct. So these are the basic public cloud, right? Private cloud. So when we exclusive use of clouds resources by single organization, ideal for sensitive data. If you want to have a sensitive data, you may want to create your own, so you have to make that cloud resource. So it's especially when it comes to a single organization or otherwise you small startup like that. If they are ideal with respect to that, they are very they don't want to make it in the public. They can go with the private cloud and hybrid cloud. Sometimes here we can combine the public and as well as the private clouds, allowing data sharing between them. One company, maybe depends on one startup, maybe in collaboration with other, like that they can come up with the hybrid like that. Or sometimes one cloud may be using with some other data which is available. So in those cases also, next it is multi-cloud. So utilization of services from multiple cloud service providers, like enhancing resilience and avoiding vendor lock-in. So especially to create the resilience, like to enhance the resilience, we have to go with a multi-cloud. So in that case, we can also stretch our idea and also our product, whatever you are working, like our services, to the cloud. So through that, we can make use of that and we can vendor lock-in. So avoiding this vendor lock-in can be. These are about the various cloud models which are there. And here, how exactly, if you see, there are various different types, like economics. Okay, so how exactly this slide shows about the information, how the information will be, right? And this covers almost the multi-cloud, we can say. So how exactly the information will be passed and it will be so like this, the different cloud sources and how the API, different APIs, and how the Kubernetes nodes can be used, and all this, how we have to pull and push the information, and the messages automatically can. Like this is one of the example which we can see here on this slide. It will help us to work to right. Coming to cloud service types. So here are the few service already everyone might have heard about this, right? We have 3 services, right? So that is about IaaS. IaaS, that is about the infrastructure as a service. So here the infrastructure provide like virtual, provides virtualized computing resources over the internet, like AWS, EC2, Azure, Google Compute Engine, and VMs. So like these are the services which are already available. So we can use. Next one is a PaaS, platform as a service. So here, but I guess many people might be using PaaS, right? So here, especially this offers about the hardware and software tools over the internet, like typically for application development. Like many of us might be working with IoT devices, right? Cyber physical systems. When it comes to cyber physical systems, they're compulsory required, right? In these cases, because we are, in fact, we are working with the hardware, right? So there you require. So like especially it also platforms to develop, run, and manage applications without infrastructure management, like Google App Engine and Hero, right? So this is about the platform as a service. And the last one, that is about the software as a service, right? So software delivered through the internet as a on a subscription basis. Like example, we can say Microsoft 365, Salesforce, Dropbox. Like these are the few I'm highlighting, but there are many also. So you can work in that way. So these are the software delivered. So there are total 3 different services. We have cloud services. So we can say infrastructure, platform, and software, right? As a service. By using. So whichever is relevant to your startup, you can make use of it, and you can work with respect to this, right? And here, the number of like this, you can, if you see the end users, when you are working with like the number of providers and the cloud pyramid, how exactly it looks. If you see the sim from it, if you see it's like a pyramid, right? So if you see here the number of providers, if you see like that, it is in different form. So end users, in this case, if you see infrastructure and network architecture, like that, and application developers and end users. So it's like vice versa. When it comes to SaaS, then it should be thousands of applications in the cloud and few cloud platforms to be like elect groups of providers, which we can like this. This is the actually the pyramid. We can call it as cloud pyramid. So like this, we can use and make use of it, and we can work better, right? And next, I want to give you the difference as I already said. I gave here how exactly they look, right? So here, just how with respect to each other, how they differ, right? So here, which cloud computing model is best for your business? Like that, you have to see and you have to choose the best cloud service, right? So here we have, if we talk about infrastructure, so in this case, if you say data centers, service and storage, servers and storage, network and security. And when it comes to platform, so in terms of platform, again, you have to the data center as well as the operating systems and the data management development tools and middleware which you are going to. So when you are coming with especially software, then with respect to software, you are again the data center is important, and with respect to cloud hosted, which application you are choosing to your. So like this, so you have to be very clear. Don't depend upon the friend said, hey, that is cool, we can go use of that. Don't, you should not believe in your work, in your idea, which one is best and which one suitable to your idea. Like that, you have to choose the service as well as the platform. Okay, so like this, if you see, and the service you can take, and then you can go for the cloud application. Like this, you have to choose and you have to work. Next, here are the PS. These are the few platforms which are already available. You might have heard also. So these are the few most important platforms which are already available, right? So these are the few I would like to show it to you all. So these are the many of us might be using, right? Next, choosing a So why? So here, when we are talking about, especially as I told you, right? So focus on application needs and business use cases, which you, right? So based on that, you have to and go for reliability than fancy features, correct? As when based on your idea, whether it is reliable to your idea or not, or with your work or not, that you have to. And native support for technology will be useful at times, right? So like this, like this, you have to think and you have to work.
Madam, please, madam. Somebody else. Madam, mute,
Yeah.
please, madam.
Right. Thank you. And better to have a provider with a good community support, right? That also you have to think and use a service that can give you free try like AWS, Azure, or others, Google. Okay, so like this you have to choose and you have to make it. And like as I told you, don't choose a provider because someone said it's cool and easy. Don't be in your domain whether it will suitable to you or not. Like that you have to. So here, if you see Amazon Web Service Cloud, how exactly? So this is the living and evolving of this. You see clearly here, you have the various applications when you are working with respect to Amazon Web Services, right? So here, we, like this. So libraries of with respect to whenever your SDKs, web interface management console, tools like AWS Toolkit for Eclipse, right? Command line interface, like these are about the various tools, whatever we are going to when we talk about the services here, like already we know it, Amazon Web Services already we are using, right? MFA, right? Authentication and authorization, monitoring, Amazon CloudWatch, right? Deployment and automation. These things we have to. And when we come to platform building blocks, here there are parallel processing, Amazon Elastic Map reduce like this. We have payments, Amazon DevOps, like DevPay, Amazon FPS, content delivery, Amazon CloudFront, workforce, Amazon Mechanical Turk, right? Messaging like Amazon SNS and SQS, right? Email, Amazon SES. And infrastructure, when we talk about the building blocks, so especially in this Amazon Web Services here, which should be compute Amazon EC2 and storage Amazon S3 or EBS also can be taken. And when we talk about network, VPC and Elastic LP, Amazon Root S3. And database, as already we know, RDS, so Amazon database. And here, Amazon is a global physical infrastructure. Already everyone knows the geographical region, availability zones, edge locations also. Okay. These are the various which part you have to see like this when you're working with respect to when you're choosing which platform or which service you want to go ahead. So you have to check clearly which suits to your work or your idea, and then you have to coming to here Windows Cloud. If you have taken this, if you have same here like execution models like virtual machines, websites, cloud services, mobile services also better with respect to Windows. And data management, like already we know, we are already in our day-to-day work also we are using, right? SQL database. Even in our Microsoft Word also you can see the SQL database, right? You can create some SQL data set, tables, blobs, even if it is Excel or otherwise Microsoft Word, you can work with. Correct? And now there that feature is also there if you see with the latest version, right? So you can work with that. You can create networking like virtual network, traffic manager, and then business analytics like SQL reporting, right? HD insight. So these things also can work with this. Right? Messaging like queues, service bus, okay, and caching like caching CDN, identity like Windows, Azure, and Active Directories, right? Media services already available, use commerce marketplace store, whatever. And then we talk about the big compute, that is HPC scheduler. Big case, as we know, we have .NET, Java, PHP, Python, Node, JS, Ruby. So all these things you can. So if you see the Microsoft latest Word, you can find all these things also. You can my PHP also, you can see SQL database. If you see that, you can create that. And cloud computing, what are the benefits when we are working with respect to startup? So here I highlighted few points which we have to be very keen while you're working with this, right? So enhanced machine learning models like constant access to high performance. When you're working with high performance computing servers, accelerate training and iterative testing of models. So whenever we talk about this, because competition time, correct? So how how we are going to reduce the completion time. That is most important. That is the reason the enhanced machine learning models to be used, and diverse AI applications like expanding usable AI technology across sector, including many things like agriculture, logistics, smart cities, wherever it is. Right. So like this, we have to think on diverse of these applications and increased access to global markets. So we have to. So like cloud solution facilitates startups to entry into international markets through global services without geographical constraints. That is also is another most benefit here, especially when you are working with cloud companies. And one most important, that is collaboration and sharing. So always, whenever you are doing, you have to, when you collaborate, automatically the international market can scale. Whatever you want, you can scalable, right? So easy sharing of resources and project among team members with respect to the one organization with other organization. Like that, we can. This is about that and how exactly. So there is a process how we can work. So here input means bet whatever you want, like a argument or validation, extraction, or you want to do classification, want to integrate. So here, how exactly this slide shows with respect to different gadgets and how exactly you can come up like this. You can input, process, and deliver the information like this. All these things with various applications you can work. You have to, that means it depends on your idea, which service you want to choose, correct? And which platform you have. About the slide shows about that. And coming to this strategies driven to startup. So here are the few leverage cloud resources early. So that means first, when startups should use cloud services from inception to minimize cost and enhance scalability, consider starting with a premium, like a premium model, like it should not be any cost because you are starting with a small idea, right? So you should not want to invest more, right? So first initial stage itself, you have to think it. So you have to make use of that. In that way, you can extend later also, right? And focus on data strategy. So whenever you develop a strong data management strategy, like less cloud data tools for storage, analysis, and for data visualization. Like this, if you have, then it will based on your activity, like as I told you, right? Go a template like goals, objectives, and actions, like achievements or actions, we can say, right? Like goals may be short term and long term. So what are your short term goals? Based on that, what is your objective to complete? How smart you are taking your objective? Okay, so like that you have to think and you have to pick. So for that also, if you use this cloud data tools, it will be better.
మరి అలాంటప్పుడు మీరు
Okay. So next, partnerships with cloud providers. So partnerships with cloud, that means you have to make like you have to seek partnerships or programs from cloud providers that offer credits and support and those dialect to start. Like this, you have to plan and you have to make with the cloud providers, right? So this slide shows about the cloud computing market in the coming years, how it's going to be. Okay, if you see here, Asia Pacific, right? So it's almost increasing every year, right? So by 2021, if you see the US dollars, like US dollars, it is about 1,266 billions of at a CGR of at about 15.1% growth will be there with respect to this cloud computing market. So this is the actual CAGR, okay, throughout world in terms of billions. Okay, so this is about the global cloud computing market. It's going to increase. So you can make use of that, and in how exactly you can make use of it and how best fit to you and how you can globalize your idea. You have to think. Okay, so like this slide shows about that. I want to give you the next how it's going to be cloud computing market globally. So this I shown to you. And coming to this slide, especially about the worldwide cloud infrastructure, like 66% of the total cloud spending, in especially in terms of 2023, recent last year. In 2024, they have taken, so especially the three major MNCs have been taken this, like AWS, 31%, Microsoft Azure, 26%, and Google Cloud, 10%. So altogether, it means others are 34%. See that. So these are the three And yesterday I already told you, right? Microsoft CEO already is going to start in India, right? Generative AI, right? So he's going to invest a huge amount of money, right? So job openings also might be there. Many are there. Okay, so think of that and make use better way of using these cloud services in your with respect to your idea. Right? And whenever you want to start up, right? Whenever you want to start, so there should be a plan, like we can call it as a business model, but here it is about the cloud, right? So how your cloud computing going to be, and how, like, means you should have come up with some idea roadmap, right? So what you are going to do, how you are going to make use of the cloud, right? So you have to do like this. So you can work with respect to your idea. Like I told here it's a business, but it should be like startup, right? Small startup, nothing but business, right? A small SME, right? So first you have to research, and then you have to plan, design, right? And you make a roadmap, development, okay, QA testing, self-testing, how it's exactly, and pre-marketing, right? Fix it based on feedback. What are the feedback you're getting? Based on that, again, you have to come up, right? So we can call here, I can also take this in different way also, like a PDCA cycle. I can also call as PDCA cycle. Plan, develop, uh, check, and action. PDCA, like that. Plan, do or develop, otherwise both you can do. Plan, others develop. C is nothing but check, because we have to check ourselves every time, and then action. These are the cycles you have to follow, then automatically you can achieve in your. So, but when you're going to start, these things to be taken at the initial level itself, right? So at the initial level only, you have to be clear what you're going to do, how you're going to come in the next 5 years, how you're going to be. Like this, you have to think and you have to come up when you are working with, you're going to work with respect to starting, right? So then again, you have to fix this, then you have to go with that. Like this, you have to launch and again post marketing and then maintenance. Like this, you have to plan and you have to work. So like this, you have to plan. There should be a plan, business model like that. So you have to take. And I'm not saying as a business model, it should be a plan, roadmap. If it is a business model, then all will come, like a technology readiness levels also will come, right? So there are total 7 technology readiness levels. All these things also you have to take. Means that will be the next point. How you exactly, because when you are coming with your idea, how you are going to make. So at which TRL level you are. Like this, you have to check yourself and you have to go step by step. Like this, you have to work. So this is about the roadmap, how you have to map and your startup when you are using with cloud. Okay? And these are the future predictions with respect to, especially about cloud computing with respect to, right? So growth of AI technologies, okay, with respect to this. That means ongoing integration of AI in various industries, like fueled by cloud capabilities, right? Right or not? So in this case, expect substantial advancements in automotive, like self-driving, healthcare, personalized medicine sector, like this, different, even in agriculture also, right? So like this, how you can plan. So these are the future predictions. Think and you can work further, right? So that means you should have some idea initially itself how it's going to be change, how, and even you should not be stick with that. Later also, if you want to add something, you can. It should be like that, flexible. Correct? Initially, I gave right the 3 important points, like flexible. How flexible you are, like that also you have to. Okay. And next, coming to the focus on sustainability, right? So that means when you are using this cloud solution, so you have to prioritize, right? Energy efficiency and sustainability, correct? Providing green, like a cloud options that appeal to environmental conscious startups. Like that also you can think and you have to. So we have already, every one of us know there are 17 sustainable development goals. Among them, which one you are highlighting? So always, whenever you're having startup, there should be one point you have to highlight on sustainability. So you have to focus and you have to be clear. Okay. So when you are working with respect to this cloud and generative AI, okay. So how green elements you have to showcase like that. Okay. So you can highlight one of the sustainable development goal with respect to your idea. So this will be next. That also gives the weightage to your startup. right? And next, another one is decentralized cloud solutions. So increased adoption of decentralized, like edge computing devices, right, to reduce latency and improve real-time analysis for AI applications. So you have to think, what are the edge devices or edge computing devices you are going to use with respect to your, like that you have to, like, with respect to various applications of AI. Okay? So like this, and that to be in real time. Okay, so think in that way, and you can. These are the future predictions you can plan and you can work further. These are the future predictions. I want to give it to you. Coming, the future benefits. See here. This cloud-based means this cloud-based in through cloud-based and AI, right? So when you these come with combinedly these two, how they're going to change. See, as I told you, like both the cloud as well as the on-premises. So cloud and on-premises both have to be taken into consideration. So that means by deployment mode, uh, how exactly in 2002, how it is going to be in 2032. Like this, you have to plan and you have to this is, see the forecast market, how exactly it is growing. So the market will grow about around the CAGR about 50% is going to increase. Like that, it will go. Correct. So in this way, you have to plan and you have to work. So these are about the size by deployment. Now see 2020, we are in 2025, it's around 192. Like that, if you see in the coming to 2032, if you see it is going up to around 1097 million US dollars. So like that, you have to plan and you have to work. These are the future benefits when you're working with respect to cloud, especially in terms of, okay. So this is another important you have, because when you're working, you have to see the market, how exactly and how it's going to be effective with respect to your startup, and you have to come up with your idea. Like this, we have to. And especially when we talk about cloud computing, how you are going to make use of it and in which way it is going to help, these all things also you have to plan. That's why I gave this slide also here. And here are the few case studies I'm sharing with you. So here, the first one I can say that is about the AWS. So here, if you see how exactly the cloud, that means the case study one, if you see here, use of cloud, how exactly they're using, right? So use of like it migrated to AWS for streaming and storage, like this is Netflix. Like now every one of you might be using, correct? So how exactly, based on the user interest, it streamlined, right? So it gives the choices also automatically. So like this, how exactly AI means utilized of AI for recommendation system. So it acts as a recommendation. So really, and even if we watch something today and if we want to continue, again it will recommend to you in the whenever you open it. Correct, like this. So that and content delivery optimization. These all things it does, right? So this is the most important way of how AI utilized with by using of cloud, right? Impact. How it means impact is nothing but achieve better scalability and reliability. Already we are enjoying it, right? So we are using it. Okay. So this is how exactly the scalability is better and reliability also there, right? It's already achieved it. And enhance the user experience with the personalized content, correct? So like this, they also personalized with based on the age, based on the different ages. Also, it can give the information. Correct. So this is the most important beauty about this. One of the case study I would like to. This is the one of the, actually it was initially it was a startup, right? But now it's a big, now it's a globally it's a big market, right? So they're doing. Next one is Airbnb. So you might have heard Airbnb, correct? So Airbnb is nothing but whenever you want to visit any country or otherwise you want to, you can opt for a Airbnb, right? So you can take, so use of cloud, how these people are doing. Let's see, again, they used Amazon Web Services for data storage and analysis and implemented machine learning algorithms for dynamic pricing and user recommendations. It automatically use the user recommendations, correct? So like that, based on the like the reviews they're taken and all these things based on the packs or otherwise based on the packs or based on the location or based on the surrounding whatever the other amenities they are providing with respect to that how they are going to do, right? If you like this also Airbnb is also one of the important the startup which has gained a lot in recent years. correct? And impact has improved operational efficiency, already they're using, and increased bookings through optimized pricing strategies, right? So pricing also, it increased, and so it will change based on the lowest to highest, how it will be, that is also varying. So like this, it goes, is increased. The next, coming to the Spotify. So already many of us, right? Spotify, you heard about this, correct? This is also one of the startup, right? So they're also using the Google Cloud platform for data storage and real-time processing, right? And AI and machine learning algorithms drive personalized playlist and music recommendations, as we know, right? So we have that flexibility. We can do that, correct? And the impact already it created, that is enhanced user engagement, correct? So many people might be using it, right? And the scalable infrastructure that supports millions of users simultaneously. So like that, the service, how the cloud service is providing. So like this, you have to think and you have to work in that way and you have to use in that way. So that's why this cloud effect, this Google Cloud platform helps in that way. So you have to make use of it. So like this, you have to think and you have to work further in the coming idea, whatever you have, simultaneously you can work. So there's a reason cloud computing along with AI, generative AI, how it's going to affect and change the market. Like that, you have to think, and in your idea, in your startup, how you are going to use it, make use of it, you have to think and you have to use it. Like this, you have to go ahead. Okay? So this is another case study which I want to show it to you. So it is already well established in the market, right? And the other one application I'm going to give to you here, that is Tesla. So again, Tesla use of cloud, correct? And this utilizes the cloud computing for data processing from autonomous vehicles, right? So the road sign, the automatic sign of the roads will be taken, and the lane conversion, lane change, automatically it has to take, right? And at the same time, AI-driven updates also, and especially on the data analytics for performance optimization, right? Here, especially computer vision play important point. Computer vision is one of the domain of AI it can take, and with respect to natural language processing, it works better, right? And by default, there will be machine learning technologies which can process the, correct. So like this, it will work, and it has to do based on the science, whatever it provides, based on those signs, it has to take automatic length conversion, learn timing, or everything has to be. In fact, already continuous improvement of AI algorithms enhances vehicle. So these also already everyone already there in the market also, right? So latest one, this is the here Zoom, right? So use of cloud. So now we are using Zoom, right? Now in this feature also they have recently, you might have seen, right? There is AI, right? So they already AI powered feature already they included here, such as background noise suppression and virtual backgrounds, whatever you want to make, and we can do, correct? So all these things already there here. So like this is also came recently, right? So they added. So like this, and scalable already we know impact during COVID-19, initially many of us might be using this. Even now also many of us using this, correct or not? So the scalable and reliable services, rapid expansion during this high demand periods. So like this, it has already created impact in the global market. So like this, you have to think how these services you are going to make use better, best in your startup, right? Or your idea, because you are going to do means how you are going to act, you have to think it, you have to choose. Coming to the challenges here, so these are the few challenges: data security and privacy concerns. So here especially important, this is very important. So importance of implementing robust security measures and compliance regulations, okay, GDPR, like example, these things, and managing cost, need for careful monitoring and optimization of cloud resources usage for preventing overspreading, right? So these things also it's very important. These are the challenges you have to, and vendor lock-in, right? So risk associated with a dependence on a single cloud provider for all services like display processors, procedures, and like, okay, pros and consequences like avoiding vendor lock-in. So these also you have to think and you have to make use of it. And skill gaps, the requirement for expertise in managing and leveraging cloud technologies effectively. So recommend training or hiring skilled personnel, whoever is required in that particular area. You have to think and you have to hire, right? Like this, you have to coming to the best practices. As I told you, to coming with the startups, you have to do first, as I told, as initially also I told you, start small. So begin with essential cloud services like test and validate before expanding, like this, and keep security a priority. Implement strong security measures, including encryption, decryption, access controls, and regular security audits. Right. So this is another important point you have to find while you're starting. Next, choose the right cloud model. Okay, so select a model that aligns with the specific business needs and scale, which with respect to your technical idea, right? Next, monitor usage. So you have to monitor regularly, review cloud usage analytics to optimize cost and resource allocation, right? So you have to do all these things regularly. Next, choose what you know, like technology, framework, or libraries. Okay, don't build if you can reuse, or a lot of good stuff on GitHub, right? So customer experience is very important. So we focus on high availability and reliability. So like this is one of the most important. Don't and next, another one is about the scalability. So go global with a distributed deployment based on use cases, right? And focus on leveraging CDNs and caching heavily to scale like that. Okay, and use RDMS level read replicas to handle read traffic growth, leveraging NoSQL stores like DynamoDB and Bigtable for high volume data. Use an auto scaling infrastructure to handle spikes in like this. You have to and try to use add-on services provided by platforms like Object Store, queuing, etc. Okay, decouple your application into different components. These are the best practices you have to follow when you're working. So these all things you have to plan initially itself. So you should come up with all this. And cloud doesn't solve bad architecture problems. Okay, but also you have to think and you have to work. Most of the good technical advice is free on web, right? So you can take or otherwise you can interact with the people also, and you can get more knowledge with, okay, because you'll get the experiences you made with it. And use community to filter choices like Stack Overflow, Quora, Hacker News, and as well as Hackers. There is no silver bullet to all problems in technology. These are the best practices you have to do initially before starting. And cloud migration. So once start with your dev or question as environment on cloud, like learn basics about related to compute, storage, networking, and databases. Okay. And also one more important is get comfortable and gain knowledge. Just few days. Okay. You have to spend some time and you have to explore yourself. Move your application without major re-architecture. It's no fixed rules, right? So like that you can start and set up a good monitoring and backup solution, right? So like this you have to think cloud migration and automate common tasks and program your infrastructure for provisioning. Like this you have to think and you have to plan. So these are, and one more important is the smartness. So choose a cloud provider with free tier. That is one important. And most providers have a startup friendly programs like a BizPack. So you can plan for those. You can attend some lectures, you will get that. And attend a conference or event hosted by providers with gain knowledge and credit points, right? If you are in an accelerator, then most of them have tie-ups with cloud providers, right? So like that also you'll get some experiences you can get shared there. We write an email to their evangelist asking for startup freebies, right? Talk to friends in ecosystem and architects from cloud providers for tech advice. And it's worth paying for a good advice. Get some from them who are working in this. Right? And not only that, you can automate deployment and focus on continuous integration. Use right tools to troubleshoot issues. Okay, never relic and pin them. Learn best practices early on web performance tuning. Okay? And leverage Stack Overflow, Quora, as I told you, and do internal hackathons to fix your technical debt. Learn from tech events in local community. Automation helps you save time, right? So you need every bit of it. So you have to plan in that way. So as I told you yesterday also I covered, these are the applications, okay, healthcare, finance, retail, and manufacturing. So as yesterday also I covered. What to give you here, coming to here. So here today, just for a recap, so here we have, right? So just we'll recap as I covered from cloud computing enables like AI-driven startups to innovate, scale, and compete. Right? So how this the applications of AI powered by cloud computing, how you are going to use it, right? You are going to take with respect to your idea, how you are going to do, and you have to take, right? So concluding, so here just I would like to convey that whatever the uh, cloud computing empowers AI-driven startups to innovate and compete effectively. Because web harness these technologies will be well positioned to succeed in our digital economy. That you have to plan, have to work, right? So especially, I can say that it's a like AI-driven startup should leverage cloud services, right, or cloud resources early. Like this, you have to develop a strong strategy, seek partnership for support, and however, they must also address challenges like data security and cost management carefully, okay, with the uh, or with your known people or with other. Future outlook will be like as AI and cloud technologies continue to evolve, startups that leverage them well positioned for like this. If you plan and execute, you will be in good position, and globally also you will. This is so, and these are the resources. Okay, we can go through. Thank you. Thank you for your attention, and I welcome any questions if you have. Thank you so much, and thank you for hearing me. So I hope I covered from basics to the with some case studies how exactly the cloud enabled, in especially AI-driven startups, how it is going to affect. So thank you so much. Any questions, please? Over to you, David, sir.
Sir, can you just go with this best practices you said, no, sir, previously?
Yes, sir. Yes, sir.
Can you give some suggestions, sir, how to go with this kind of best practices? Any case study, something like that?
Yes, sir. Yes, sir. Best practices, that's same thing. So what we have to do, we have to plan. That means first we based on our idea. So how which platform? That means based on because the idea will be person to person, it will be unique, right? So based on their idea, they have to first select the uh, the platform service which they want to use and which technology they are going to work, in which way it's going to uh, work, and globally how they can emphasize. So for that, what I suggest first they have to come up with idea, and with respect to that idea, first they have to come up with the business model. Like means they have to come up with a roadmap, and then if they have the roadmap is clearly, if they write the roadmap clearly, then if they will go and meet if any person like in hackathons or otherwise in pitching events, if they go and present, because in pitching events many people they ask about, because it's a startup, right? So to get the angel investors or for the finance support if they want to get, so how they get, they have to attend the pitching sessions, especially each and every uh, company or otherwise any IT people, they will ask about your model, like roadmap. What is your roadmap? Which platform you are going to use? What is your technology? So you have to plan everything. So that is the reason. If it is a small idea also, it should be clear how it's going to be. Now how it will be, next how it's going to be, next 3 years, next 5 years. What are your ideas? These points you have to put in that. Like you have to create a roadmap. So if you have that roadmap, automatically how that itself shows the confidence and the strong sustainability of your technology, correct? Your idea. It gives the impression to the people, angel investors, or otherwise the freelance, like the financials who will be there in the company, there to take that idea, to sponsor that idea. So you have to come up with this. Okay? So this is what I can tell it, sir. So you can start with small and how flexible it is and which platform you're using. Like that, you have to plan and you have to come. clearly with this, and try to attend more pitching sessions so that your idea may will catch up and you can go ahead with start with some funding. And once you have funding, you can go. Correct. So like that, you can increase your market, increase your product, and you can go globally also. Is what.
So free tools, can we utilize any of the free tools, sir, in this?
Yes, sir. We have that resources. These resources, they get some input here. Whatever the resources as I shared here, you will get some information and architecture you can get from here. So I suggest you can go through these links. You get the.
In previous slide, sir, you said that some keep security a priority. Something you said, sir. Can we keep that security kind of thing, sir?
Yeah. Security, especially. Right. Exactly, sir. Because when you're working with your idea, because security is one of the most important, right? So you should be very clear because when you're working with cloud, so what are the security measures you are taking? So that also, either for encryption or decryption, what techniques you are going to use, which technology you are using to for that, to secure for that. So these things also you have to highlight securely, how you can manage and how you go ahead with that, either by using blockchain or otherwise nowadays you have other techniques also, right? So nowadays deep fake is also coming, correct? Deep fake also, like that is also another one. I'm not talking about. So like that, you can plan and how secure you can maintain your idea or your startup or your organization, how you are going to make. So these things you have to make clearly. You have to work on that. So these are already there.
Okay. Suppose if the students are willing to do some biometric systems, sir, for all the students as a project now, that they want to use some CNN techniques, some deep learning techniques, and they want to implement it for almost 10,000 students, sir.
Okay, that's good, sir. And cloud, you are working with server or cloud? Like that, we have to plan.
Cloud, sir. They are planning for cloud hosting or something like that.
Yeah. So cloud, if they are working, if they are going with Wi-Fi or if they are going with the mobile, which data they're going to use, that also matters. Okay, because when they are working with the Internet of Things, they're going to capture the biometric of 1,000 because it has to real time. It has to work, right? So in real time, how the data will be captured? Even only with biometric they're working, or face also they're working.
Biometric face recognition, sir.
Face recognition. Even with they're working with faces also because the data, because they have to capture the first data, so they have to maintain. So this how the data they're collecting. So that is also matters. Which type of data, how they're collecting, how they're storing, and how the processing they're doing. Like when they're real time, it has to process, right? Once the in real, if they want to go for attendance system in class, automatically it has to do the attendance with these people are present, right? Based on the face. That means you have to capture the images also with of different faces, right? Of the same person. Like this you have to create. Because people also sometimes they create AI images, right? So how it affects that is also important. So like that, they have to correlate and they have to work on the data, which type of data set they're using, how these libraries are going to use with respect to our transfer learning algorithms, how they are processing through convolutional neural network, what you said. So how it's how it exactly pooling the data. That is also important. And what type of data. So these things to be clearly they have to point. They have to clearly they have to identify and they have to set. Like that they have to plan. And even along with CNN, if they use LSTM also is better, as per my knowledge, when it is coming to attendance and face as well as biometric. So that also does good in this. Along with CNN.
State governments, they are providing small cloud storages, sir.
Yes, sir.
STPI, some centers that is existing at Hyderabad, Vijayawada, Bengaluru, something like that, sir. The software technology parks of India, like that, they named it like that.
Yeah. Exactly, sir. Even CDAC also providing with them.
Okay.
Like that also we can hire, sir, because nowadays the lot of data is available, and even they are making cloud also, because they're investing a lot. Actually, government itself is investing a lot. So that's the reason they want to mobilize everywhere. So the students have to come forward and they make use of these services because they're free on small data. And by using the small, because first they have to register, right? They have to write, register, sign up, and they have to register, and what type of, how much of data packet they want. That also they have to give prior information to them. So like that, they give the login credentials and they can use that. So with this, so like that they can use, and if they have some graphical user interfaces, then they can use like that from there also. From local servers also they can access. Like that also they can plan.
Okay. Can we suggest clouds among these? That means Google is there, AWS, Azure, different kinds of service providers are there, sir.
Yes,
Among
sir.
these things, which one can we elect?
It depends, sir. Actually, AWS is good, but based on the idea, student's idea, which one? As per you said, biometric and this, AWS is okay. AWS works good.
Okay.
Yeah.
For this deep learning, we are using this collab something, sir.
Collab, actually, Collab is a platform, sir. Collab, we can process whatever the input. Actually, I thought because in my natural language processing, I use sentiment analysis. So sentiment analysis, I can take from the data, I can give some data, and I can process through Collab. Because Collab is user friendly, it's open source, and each and everyone will enjoy. Because whatever they do, they get the result there itself. They can run and they can see. Because it's a free, it's open source. Right? Whatever the script they have, they take that script and they can do here, and they can process. They can run that, and they can see. Right? Like a sentiment analysis, like I can, based on the conversation, I give some conversation, and based on that conversation, whether the people in that conversation, how many are sad, how many are happy, how many are crying, like that. Like these analysis, sentiment analysis, we can create from the content. Like this language model I have, so that I'm working, and so like this we can work and we can do. Next, students can think in that way. Yeah, this example I told in this, like that they can see another also, like that. So Colab is very good. It's open source. We can use it.
For
Even
MBA postgraduate students, sir.
sir,
Yesterday they approached me and then asked me that, sir, how can we start our learning for
yes, sir.
this AI and then the cloud, and we are not utilizing them. Just we are thinking about finance and HR in that area, sir.
Yes, sir.
How can
So
we go with
what
kind of
I
AI
suggest,
and
sir, Coursera, like LRS, like for education institutions, we have free versions, right? Like Coursera L4G, right? You might have used earlier during COVID time.
yes,
Also, you might have used, right, sir? Government made it.
yes, sir.
So through Coursera, there are the few courses, like especially on cloud computing, data analytics, and AI, generative AI. Few courses, they're free. Like they're the the recorded lectures are there, and there are some few tests also students can take multiple times. So like that they can explore, and even the lab task, hands-on sessions also available. So through IBM and through Coursera, we have that. So they get certificate also. They can use that. So they can register under that through institution mail ID, and they can work, they can explore knowledge, and they can do some work also. Hands-on practice also they can learn. As the initial starters, they can do that. Good platform. They can use them. You
Okay.
can find, sir, that is LFG or L4G. I didn't remember. Coursera, they provided. We have free version for students. Even for faculty also can use with official email IDs. They can learn. And they get certificates also, IBM certificates, like that they get. So they can use them. And they can learn, especially multiple times, they can give tests and they can explore. And recorded videos also there. So that is easy. So you can guide them to go for that and they can see. even business analytics also there, DevOps also there. They can find the courses. You can see, sir, few basic introduction courses are available. So those I can suggest for understanding purpose, studying and learning. Even hands-on practice also there. Some sessions also there. Small tasks they gave in that.
Thank you so much, sir. Any
Thank you, sir.
queries?
Any questions if you have? Any questions if you have, you can ask.
If no queries, we can go with the other session.
Anybody having any questions, sir?
Sir, thank you so much, sir, for your loving, kind talk, and then it is very inspiring, sir. Thank you so much.
There is one question, I think, sir, in
Definitely,
chat.
our team members, all our participants, will get much more insights from your talk.
Yes, sir.
Definitely, what we expected that we have achieved, sir, with your talk. Very nice
Yes, sir.
talk, sir. So thankful
Yes, sir.
to you.
I think there is a small question in the chat box, I guess. BitSpark, they're asking to ask about the BitSpark. Actually, BitSpark actually is a program launched by Microsoft, right? Correct? As
Yes,
I'm
yes,
not
sir.
wrong. Yes, sir. It's a Microsoft launched program, right? Especially support to startups, correct? So,
Yes, sir.
like a early idea, like a idea stage. When you have idea stage, so you can talk. So you can use this BitSpark. If you have an idea, based on that idea, like based on as I told you, the technology readiness levels. So how you are going to come up with your design, first from idea to design to prototype, and then prototype to your model. So like that you can plan. So in those cases, whatever the software or cloud resources, whatever with respect to your idea. So here, Microsoft launched this BitSpark. It will help either in terms of cloud or otherwise in terms of technical support. They are here. But idea, you have to come up with your idea. Like, and you can use that services and you can work on that, right? And even if it is secured and is also secured and it's a good ecosystem. So like this, you can work. So, and one more important is their prototyping and development also you can done easily there, right? And later you can also change. This is about the BitSpark. I remember what right? So with the basic idea, you can work with respect to that. Okay. So I
Sir,
hope
any best practices, then please leave us some links, sir.
Okay, sir. Sure, sir. I'll share.
What your practices over there
Yeah.
in your university,
Yes,
so that we can initiate those
okay,
tasks.
sir. So I hope, yeah, sure, sir. I'll share later.
Yes, sir.
Okay, sir. Sure, sir. I hope I covered as per the title from the
Yes,
basic
yes, sir.
introduction.
You just pretty lot, sir.
Thank you. Thank you so much, sir.
Thank you, sir.
Thank you, sir. Thank you, everyone, for bearing me. And thank you so
Thank you,
much.
sir.
And I thank Vasavi Engineering College for giving this opportunity, for me. Thank you so much for inviting me also. And I hope I gave some insights to you or some takeaways to you yesterday and today. I hope if you want to connect with me, you can connect later to David, sir. Okay.
Okay, sir. Okay, sir. We will proceed, sir. Thank you so much, sir.
Thank you. Sir.
No, thanks.
Thank you. Thank you, everyone.
Let us take a 2 minutes break and then we will continue with our next session. Just 2 minutes break. Don't leave the meeting. Just let us have 2 minutes break and then we'll continue with our next session. Let us resume our sessions. Now let us start our second session of today's talks. Optimizing AI workloads on the cloud, uh, techniques for efficient AI model training, and automation of cloud platforms, including resource management. This is the talk already we had already Pani Krishna sir's lecture yesterday, the day before yesterday, and we are going to have one more enlightening session now. Let us welcome our Pani sir to give his talk. Pani sir.
Yes, sir. David, sir.
Okay.
Uh,
Thank you, sir.
first,
Now I hand over the time to you, sir.
okay, sir. First of all, thank you for giving me this opportunity. Thank you for Srivas Engineering Management, David Garu, and the HOD ma'am. So let me straight away jump to the talk part. 1 second, let me share it. Use system desktop. Okay. Sure. Yeah. Yeah. I believe the slides are visible and I am audible. Yeah.
Yes, sir.
Okay. Today's session will be optimizing AI workloads on the cloud. We explore some techniques, strategies, and practices. So one thing we have to understand is optimizing of AI workloads on the cloud has been more than a decade old practices. Like it has been incepted way back 1 decade back. The first time I came in touch with this kind of a strategy is when I was asked to mentor for AI as an AI architect for a startup. Basically, this is way back in 2017 and 18. I was I was asked to mentor for designing a semantic segmentation, basically a image semantic segmentation, where two people from two different places, if they send their photos, we are supposed to remove their background, merge them together, and put them in a new background. Okay. So the basic idea is if one person is in Italy and one person is from Paris and they want to take a selfie together, so the background will be overlaid with one of the backgrounds of the friends. So it looks like the both of the friends are in the same place. So that was the basic idea of the startup. Now we have designed a very good AI workload way, right? We designed the mask. We have picked some of the state of the art at that point of time, which is mask CNN, and we deployed it. We quantized it, optimized it, and we have deployed it. And also we deployed it on AWS at that point of time. Till that point, we are working on a premise server, and we deployed on cloud. Now, as the people keep on growing up, okay, as the people the requests from the people are going up, so the cloud has helped literally to scale up over the night to achieve what the company thought of achieving. Okay. Later on, they pivoted the idea and they have licensed out the technology to some media house. But I have seen how on-premise tech, whenever you're developing and deploying it on-premise, but when you take it to the cloud, what are the things that have to take care of so that you can have the most efficient outcome on the cloud? That's the first thing I have seen. The second thing is, that is one case. The second case is after getting into NIT. So one of my student is developing some algorithm as a part of a project, and the training part is very cumbersome. It takes a lot of time for machine learning and deep learning technologies. So whenever he has to train a particular designed model on the particular data set for say 100 epochs, it used to take 2 days, like 1.5 day to 2 days for him. Now, at that point of time, we have closely looked at seen the algorithm, and we thought, why don't we push it as a distributed computing? And we have distributed the data and the model, and we have pushed onto the cloud, and we are able to achieve this 100 epochs training just in 3.5 hours, 3.5 hours to 4 hours. Like what is to take like 1.5 day, it has completed used to complete within 1/2 day or 1/2 of a working day. So that is when we started to explore how can we optimize our AI workloads on the cloud and various techniques and strategies. We have to keep in mind different AI workloads demands for different techniques and different strategies. As the previous lecture has clearly pointed out, there is no silver bullet for all problems. So any workload, AI workload, defines or demands for its own particular strategy and technique. So with keeping that in mind, let us move forward into this today's session. So today's session will be just a bit, initial section will be um, initial part will be introduction to the basic cloud and why the cloud and everything. But as I have seen that already the previous session has covered it beautifully, I will not go through the things again, and we will be taking up the practices of what optimization techniques or how the optimization techniques are employed for architecting and by an cloud architect for cloud optimization, And we'll stress more on, as a developer, how can you make this AI training and AI inferencing more optimal way. So we'll be discussing at less space on how AI architect can optimize how AI architect optimizes the things, but we'll stress more on how, as a developer, you can optimize your training pipeline or inferencing pipeline so that you do not overhaul or overburden the cloud. Okay, this is a two-way approach that we pick. So coming to the first section again, so you know why we need a cloud computing. Previously, we used to have something like grid computing and all these things, but people have slowly migrated from grid computing to cloud computing. So because you can scale up easily, flexible easily, and you can connect with various devices. So with that aspect, this cloud computing has been popularized, and and as with this nature of this cloud is very much in sync with the demands of AI, because AI, if you look when you're training AI for different phases of AI, it demands for different kinds of a compute. Suddenly it spikes, suddenly it reduces the compute point of view, suddenly it requires more RAM, suddenly it requires more space, memory storage, suddenly it requires more clock speed. So there will be a dynamic highs and ups for resource requirement while training an AI and deploying an AI. So cloud computing is a perfect fit for that. And second thing is, in current generation, the AI models are growing huge. That is, previously when you are able to train an AI model on your laptop or a system or an remotes on your local server, but these days AI is so huge, you cannot run it on your own system, okay, or any system in your premise. For one example will be GPT. So GPT model, even though they say, okay, this is my architecture and use it, you will not be able to use it because you will not have any infrastructure in your hand to run the GPT. So for that reason, cloud computing is the backbone of the modern AI. Okay, and cloud offers a scalability, flexibility, and compute density and cost effectiveness. Okay, because it has pay per use. You can, if you have an demand or you have an use case, you can go to the cloud, use the compute, and you can shut down. Okay, but if you have something, a server on your premise, that's going to give a running cost for you throughout, as it is long staying in your campus. So one example is, if you bought a server or if you have a computer, one example is the lab computers. We have lab computers, right? So how effectively do we use our lab computers? Out of 7 days, maybe we'll use 5 to 6 days. Even in these 5 to 6 days, we'll use only 8 hours on each day. So effectively, you're using less than 33% time, the resources. Okay. So that is not cost effective, like price to value kind of a thing. So that is why you can go with the cloud, and cloud platform hosts enterprise grade modules also, because in current generation, as the cloud providers are improving themselves, so they're not only offering just infrastructure for compute, but they're also giving a software stack so that you can deploy your apps, applications, softwares, products, storage, whatever it is, at with enterprise grade. So that is one is the advantage of cloud. And AI on cloud adoption. Okay, because it is a necessary, because data explosion is because data keeps on coming and you have to scale. You cannot scale if your server is on premise. Okay, so but if it's on cloud, you can, based upon the data that is coming inside, you can keep on scaling up on the cloud. Okay, and you have a seamless deployment, because the architecture infrastructure is again supported by one sort of an cloud architect, IT admin, system admin, and all these people. So there will be a seamless deployment and technically supporting team for you. And of course, increasing AI model parameters. You cannot host any existing top-notch model on your local premise. And being a student to researcher to a company or an academia, so it has they opt for cloud for various reasons. One is the cost reduction, improved performance, scalability, reduced environment impact, improved model accuracy and generalizability, and faster iterations. Okay, well, these are various reasons why people go for cloud. Now, as in today's session is stressing about, so how can we optimize things? So there are two ways of optimizing it. One is a request is coming to the cloud, and there you can optimize where it should go. The request should go onto which slot it has to go, or which compute it has to use, something like that. Okay, what instance it has to use, something like that. That is optimizing at the from the cloud architecture point of view. One is the application development of point of view, because there you're putting a request and you're asking, okay, I need this much of RAM, this much of storage and everything, but you can optimize your workflow and during the training pipeline or deployment pipeline. So whatever the resource that was given to you on the cloud, you can effectively use it. So one is you as a user effectively using it, and the second one is, or the first one, cloud architecture, is when a request is coming from a user, how being an AI architect can effectively manage it. Okay. Now, whenever you are looking at workloads, so usually you have three kinds of workloads from AI perspective. So one is the training, that is when you're training the model or these things. And second is the inferencing. Okay. So when it comes to inferencing, that is you have a trained model. Okay. You have a trained model. Now the model should go into the hands of the user so that the user can use it, or your end user, because you made a product, you trained the model. The model should be used by somebody, your customer. So when you're using it, so that is termed as, that phase is called as inferencing. So during the inferencing, again, there are two kinds. One is the batch inferencing and real-time inferencing. So batch inferencing is, so your customer is requesting you, and if you are giving the response in real time, okay, so something like autonomous driving, or flight controls, these places, right? So you cannot have any kind of a delays. So when a request comes to the cloud, you have to respond to it. Okay, so that is the one kind of inference. The second kind of inference is a batch inferencing. So batch inferencing is, people are okay, whenever you are uploading any kind of, when a customer uploads for a request, so they will not do immediately, when until they come, some sort of a batch comes up, pops up, and they will do it. Something like Zomato orders and Swiggy orders. So even though a single the moment they get a single order, they might not be doing it, but if they get couple of orders or three more orders, so they will do on the way, kind of a thing. So this is three ways of workloads you have to keep in mind. So training is constant across, but when it comes to batch inferencing, you have to keep two things: batch inferencing and real-time inferencing. Now, as you have to do these workloads, you have to understand what is the basic architectures, or what are the services that the cloud computing will give. That is infrastructure as a service, product as a service, functionality as a service, software as a service. Okay, these are different architectures that cloud computing will provide to you. So actually, even though they are named differently, but they're actually one is an stacked over the other, kind of a thing. Infrastructure is where you will be given only infrastructure. Okay, so on top of it, products, if along with the infrastructure you are given certain products like already pre-trained models, or PyTorch installed, CUDA installed, TensorFlow installed, like some certain products were already there along with the infrastructure, then PAS. So when it comes to SAS, it is like, okay, so not only the basic libraries and functionalities, you have a complete pipeline of software in which you can play around. So that is software as service. Okay. So this is the various types, like infrastructure, IaaS, PaaS, platform as a service, and ready to SaaS, software as a service, and serverless. These are the four kinds of thing. Each has its own advantage and disadvantage, because when it was given an IaaS, you have higher flexibility. You have a you can customize your hardware and customizable hardware and stuff. but the issue is the higher maintenance overhead. That is, you have to be like a system admin or somebody who can delve through and you can articulate it. And platform as a service, so for the model deployment kind of a thing, you have ready-made certain AI ML services readily available. So you have a reduced management and faster deployment, but you have less control over your framework or anything like that in comparison to IaaS. And coming to SaaS, as you have going up to the pyramid, your life becomes simpler, but as a developer, you will be losing your control. Okay. And finally, serverless. So whenever you don't want to have take this all this kind of an headache, so that will be the you will need a least skill to use that kind of a service. Okay. Now, as we said, when a request come to the cloud, as a AI cloud architect, what they will be doing is a user, like a customer will be asking some sort of a request through the internet, and there will be a load balancer sitting there, and it will say, okay, I have a set of servers and various instances. So where should this request be passed to? Because I should be optimally allocating them so that I will be using my infrastructure effectively, and I will not be losing any new incoming user requests. So basically, this is how it looks like. Whenever a user requests, the multiple user keeps on requesting, so the request will go to an DRL ML based methodology. Okay, so that will allocate certain instance or resource in the cloud, and it is an service agreement. Is it accepting the agreement or not accepting the agreement, service agreement? So if it is accepting, okay, sorry, it is violation basically, but actually it's an agreement, SLA agreement. If it's agreeing, that means it will go to the bottom part and it allocates to a VM, that is virtual machine. Okay, so and the results will be going back to the user. If it is not, then it again goes to the DRL, and now DRL or machine learning model will be taking up new resource allocation, and it will be until the SLA violation, like SLA agreement as accepted. Okay. Now, people have been adopting various combinations of techniques also, because here we have mentioned about DRL or machine learning based method. So DRL is deep reinforcement learning. ML based methods can be employed. So sometimes you can use machine learning methods like which is ANN based with optimization methods also, which is BPSO, which is binary particle swarm optimization. So you know, in this case, it is purely ML based with a load balancer, which keeps on giving the feedback. Here it is ML plus an optimizer for your allocation of resources. Okay. And for majority of these ANN or DRL ML based methodologies, this will be usually a sequence to point methodologies. That is, you will get an temporal sequence as input for that model, and it will be predicting, okay, which allocation or which resource it has to give. Okay, so usually they prefer CNN plus LSTM combination. So CNN picks up the local features, and those local features will be based upon those local features to construct the temporal features. So LSTM will be used on top of CNN. That's why CNN should be followed by LSTM. LSTM will come second. The first part will be CNN. But people are also exploring other approaches like transformers and all these things also. Of course, transformers and everything is meant for NLP based task. But if you see, the transformers are also brought up into the vision space through vision transformers. So into the signal processing also they're bringing. So you can have that kind of a temporal analytics of signals using transformers also. Okay. Now, this ends how an AI architect optimizes his infrastructure using AI and a load balancer. And let us look from now, let us switch places and let us see we as a developer. Okay, we as a developer, okay, if we are given an instance by the AI architect, one instance has been given to us. Okay, whenever we are requesting certain instances, usually we ask for majorly two or three things. Okay, one CPU, central processing unit, is for sure, because that is the brain and heart of your compute. So CPU is something very much needed. And you ask also GPUs, because you will be aware by this point of time. So for running majority of AI algorithms in a faster way, or in speed up your training process or speed up your inferencing process, so there people are using GPUs also. So how many GPU? Okay, you will be also allocated GPU, and also TPU, tensor processing unit. So tensor processing unit is a hardware that is designed by Google. And if you write your code in say TensorFlow, it is said that TPUs are effective to run, are more effective to run with TensorFlow. If you go to Collab also, if you are go to like a high memory kind of a thing, you can environment management. If you go there, you can see that you can turn on a GPU, right? And also you can have access to the TPU also. Now, CPU is meant for general purpose processing. So you can do any sort of processing, right from data pre-processing and all these things, and software management tasks, and all these things can be done. And model management thing kind of a thing. So those are the major need of the CPU. Coming to GPU, that is a parallel processor. Okay, so it optimizes. So whenever you have matrix multiplications or algebraic applications, so which can be parallelized. So then those kind of a computes which can be speeded up with parallelization. So there the GPU is going to picture. But in GPUs again, you have two kinds of like CUDA cores, tensor cores, these kind of cores will be there. So some which are good with linear algebra, some are very good with tensor, some are very good with matrix multiplications. So what TPU came up with, when you are having convolutions, so to speed up the convolutions, so the TPU cores are specifically designed so that you can better run or fastly run your convolutions. Okay, because they have more number of tensor cores. Now this is an outlook of where do you use CPU, where do you use GPU, and where do you use TPUs. And also initially Microsoft has put its lots of bet in FPGA. We'll see that part also. So whenever you have an small models, you can utilize it, and you don't have large computations, and a large amount of data need to be churned. So there you will go with CPU. When you have large amount of data and you have medium to large models and large data sets, and when you are using image or video processing or natural language processing also to some extent, so then you will be going with GPUs. So that kind of a workload need to be pushed onto GPUs. But if your operations have a lot of convolutions and matrix computations and dense vector processing, so in those scenarios you will go with TPU. And you want to have a compute intensive applications and high performance to cost ratio, people will go with FPGA. But as TPU is for designed by Google, if you go with AWS, usually CPU and GPU are straight away available and you can use them. And as AWS is headed by Amazon, and they are trying to bring in CPUs, because whenever we say CPU, we have Intel CPUs in mind, but they're also bringing the ARM Cortex based architectured CPUs also. And based upon the same architecture, they are extending it to GPUs also, because till this point of time, CPUs means Intel for us, GPU means NVIDIA or AMD. But now AWS and other people have been investing a lot in other architectures based CPUs and GPUs. Okay. And type of along with the, because okay, one thing is the processor, which is one of the heart and thing, but again you need a good memory storage, right? and also you need good network. So even those things has to be kept in mind. So to speed up those things, you have to keep the object storage. So because when you make it into objects and store it, because in AWS also you have an S3 buckets kind of a thing, so which makes it cost effective, scalable, and storage for large data sets. Okay, because in your machine learning model during training in particular, you will be going to the data, fetching it, pushing to the model, and updating it. Again, you go to the database, you pull out a data, and again, you update your model based upon the error. So it is an iterative process. So you have to go through the data lots and lots of time. So you have to keep that object storage and block storage also keeps in you when you are availing those features, it will be helping you. And second is the bandwidth and latency, because during the inferencing point, so whenever say a chat GPT, you are asking for a request, okay, you're sending a command or prompt or something like that, and you're expecting a response. So the response, even though it is high compute, the computation has been done. So you have a good GPU, good CPU, and the memory also has supported very well. So the output is ready, but output should come to you. Okay. So at that point of time, the latency and bandwidth will be playing a role. And second thing is, for people who are when they're dealing with multiple nodes in the cloud computing, when you want to handle with multiple nodes, so sometimes a single model might not fit onto a single node. That is, node means one compute node. So maybe you have to stretch it across two compute nodes or three compute nodes. At that point of time, the communication between the compute nodes also should be very high. So both inherent processing power and the communication between the compute nodes can make your training faster. So when you mean bandwidth and latency throughput, we mean the response latency, and also the latency when multiple nodes has to communicate between them while training or while inferencing. When I mean compute nodes, which is they both are still on the cloud only. And you have to take various key performance, because whenever you are doing any kind of an optimization, it might be helpful for the AI architect and also as an app developer or application developer and a AI developer. So you have to keep in some key performances. So what is the right sizing of compute instance, workload characteristics, compute hardware, memory, networking, and also when you're doing it, key performance, you're supposed to take into account the cost, and sometimes you are supposed to take into account the carbon footprint also. So these are things which you have to keep in mind. So from a compute point of view, how can we optimize it? Okay. So one is efficient data loading. So what do we mean by efficient data loading is optimize how data is loaded onto the GPU. Okay, so we are speaking from the GPU point of view. So how efficiently can you load onto the GPU is one thing. So usually rather storing it in using various libraries. So in TensorFlow they have this TF data, and PyTorch has a data loaders. So when you say data loader, there, which is as a part of the pipeline, the optimize the loading part, there will not be overhead on the loading part of the data, because unless the data hits the model cannot do a forward pass and a backward pass during training and error back propagation. So there is one more method. One is they're using what makes these things very effective or efficient is, say your model currently which is already on GPU, has nth batch. So you're training with the help of an nth data. So nth data is given to the model, and the model will predict as an output. Okay. During this time, your processor might be sitting idle, or one of the threads on your processor might be sitting idle. So what you can do is you can use that processor thread to fetch the n plus 1th data. That is the data which you will be giving in the next step, so that the moment the model on the GPU has done its forward pass and backward pass with the nth data. N plus 1th data has been prefetched by the CPU. So this way, there will not be a overhead or hacking or logging, staying back of the GPU. So, okay, I did my forward pass, I did my backward pass. Let me wait till the I fetch the next data. No, already the next data is pre-fetched by the free thread or a free core of your processor. So those kind of a data loading and data parallelization techniques will be handled by this. Okay. And second thing, if, as I said, when you're having multiple nodes, so management between multiple nodes also should be handled, because, okay, whose data has gone to whom and whose gradient should be updated, because and during error back propagation, the gradients will be coming and stuff. So those handlings should be done. Okay. And next is the batch size optimization. So when this is a very hurting thing for me, particularly for me, because when I have a server and which is of like 96 GB GPU, so usually what people do is they develop a model on their local premise system and they bring it and dump on my server. But when they're doing it, they don't increase the batch size. So because on their premise server, maybe the batch size of 8 or 16 is sufficient, because they might be using a 16 GB GPU or a 24 GB GPU. But here the GPU competency, like I have multiple GPUs and it can support up to 96 GB GPU. So, but yet they're using only 1/4 of the resources when they were given, because a simple thing, they couldn't do a batch size optimization. It is not even a harder thing. All you have to do is, okay, for four batch size, how much RAM it is taking. For 8 batch size, how much RAM is taking. So these are things that they have to look into. Nothing more than that. So it is batch size optimization, but you have to take one thing in mind. Sometimes people overburden thinking like, okay, RAM is in the process of overfilling the RAM, you should not compromise on the clock, because RAM is like a cargo ship. Like you can host lot of data on the cargo ship. Clock speed is like how much fast this cargo ship can go. So in the process of overweighing your RAM, you should not compromise on the clock. Okay. So that is the batch size optimization. And next is the mixed precision training. So mixed precision training is whenever you're training your model, weights are allocated to your model, and those weights will be like 64-bit or 32-bit. Usually GPU will be doing with 32-bit. It's a single precision. But sometimes in some layers, maybe you will not be needing 32-bit 32-bit numbers. Maybe you'll be needing only 16-bit numbers. Maybe you might be needing only 8-bit numbers. So you can have a mixed, like some layers can have certain precisions and certain layers can have certain precisions. So you can have an mixed precision training, so which reduces the memory, because you can have a larger models. When you do such kind of a mixed precision, no, you can actually increase your model size, because a model, if it's like a 32-bit, each one with an 32-bit, so it takes a certain space. But if you change the model to 16-bit, so usually it takes lesser space. So you can include more and more parameters, so that you can have a bigger model with the same, with more number of parameters, but you have quantized those, or you have the precision has been traded off. So it reduces the memory size. Now, one more thing is data parallelization and model parallelization. As I said, during your cloud computing, you will be given access to multiple nodes, okay? And even on single node, you can have multiple GPUs. So when you have multiple GPUs, you have one of two options. One is data parallel and model parallel. So you have a model which fits straight away onto one GPU, okay? So then you go with data parallelization. Okay, so because the same model will be cloned onto multiple GPUs, and but the input for that model will be, the data will be different. Okay, it will be like nth data for device 1, n plus 1th data for device 2, n plus 3 data for device 3, and so on and so forth. So here what is happening is, say first iteration, you have to deal with first batch. For second iteration, you're supposed to deal with second batch. For third iteration, you're supposed to deal with third batch. So if you have single device, GPU at first iteration, it will be taking first batch, second iteration, second batch, third iteration, third batch, and so, and it updates its gradients. And it will update its weights. But when you have two devices, say two GPUs, so in iteration one itself, batch one and batch one can go to device one, batch two will be going to the device two. But the model will be the same in the both the devices. So the same model, same parameters will be there. So it produces an output, it computes an error, and the model will be simultaneously updated. So this way, for each iteration, you're pushing two batches. So for an epoch, the complete epoch is nothing but the total number of iterations will be reduced by half. So this way, if you are having more number of devices, so the number of batches can be scaled horizontally, and the time taken to go through each epoch will be reduced. So that is data parallelization. Model parallelization is running multiple parts of the network at same time, because you have one big network that cannot fit onto a single GPU, because a GPU might be 24 GB or 48 GB, but your model might be like 100 GB, 200 GB, or 300 GB. So as it cannot fit onto a single device, so what you have to do is you have to break the model onto multiple GPUs, but you will be sending, or you'll be using only one batch at a time only. So batch one will be given to the first part of the model, the output will be given to the second part of the model, so on and so forth, so that you will be getting an output. So through model parallelization. So when you want to fit bigger model, you'll be going with model parallelization. If you have already a decent model which can fit onto one GPU, but you want to go fasten up your training process, you will go with the data parallelization. And coming to TPU, so TPU is usually chosen when you have more matrix intensive architectures. So this is TPU optimization. So you take only TPU when you have like something like ResNet or DenseNet, something like that. Okay. And you can also do an optimizing the input pipeline. That is, you have a particular data set. So you can have a TF data experimental service distributed, or these various pipelines, which are like part of the data loaders, which can help you to speed up your process. And you also can take large data base batch sizes, so you can experiment up. And one more thing, as it's a TPU, you can have an accelerated linear algebra compiler. So XLA is like whenever you have a model that is designed in Python or somewhere in TensorFlow, you can actually have an XLA accelerator. That is because when you have compilers has a bigger role to play during the XLA. So when you have such kind of a compilation, then it runs very beautifully. Okay. And the third one is when you're having containerizing. So this got nothing to do with the devices, but it is more about how previously, as I said, if you recall, we have virtual machines, right? So in the cloud computing, we had virtual machines. Those are at one point of time. But now, if you can, containerization is deploying and managing workloads in the cloud. This is very good in deploying and managing AI clouds. But one thing why people are going with this is its portability, scalability, and resource efficiency. When I mean portability, scalability, and resource efficiency, I don't mean from the perspective of cloud. I mean from the perspective of containers. And this technology like Docker, Kubernetes are helping out to containerize your application. So what does it actually do is it packs your complete application and dependencies into one unit or one container. So whatever you want, okay, you want to run an application. So this application needs certain softwares, needs certain dependencies, needs certain functionalities. And why this is very much needed, because sometimes when you are doing a certain application, a particular library should be of particular version, a particular library should be of a different version. So that crazy combination of libraries sometimes make a developer's life like a hell. Only people who gets their hands dirty while coding will get to know this, because logic is good, your logic is correct, your program is efficient, and there is no errors, yet your model will not get trained as is has been expected, because suddenly something will pop up saying that okay, this functionality will act, this function will take only integers, but previously that code was working, but now it will not work out. Okay, so why dockers were popular? Because in developer community, you can give to your client or you can give to your boss saying that okay, this code is working, but when your boss or your team lead is running it, it is not working, then he can say that okay, it worked on my computer, I don't know what happened to your computer. So that kind of excuses cannot be given anymore. So the dockers will be packing the, when you're giving a docker, that means you're packing everything and you're giving them, so that unless there is a mistake in your logic, everything has to run as it has run on your machine. Okay, and when you want to orchestrate such kind of containers and docker made container images on multiple machines or multiple docker units, so at that point of time you get Kubernetes. Okay, so one beauty is both of them are open sourced and they're freely available, so you can play around with them. Now this is gives a basic difference between a virtual machine and a container. So this is what makes container more portable, efficient, and optimized. Because whenever you want to run an application, so in VM you will be having a hardware on top of which you have an OS, on top which you have a hypervisor, and on top of it again in your this particular VM you will have an guest OS. Again you have libraries. On top of that you have an application. Now here, but when you're coming to the container, so you have a hardware, host OS, but you have a container engine. So instead of having a hypervision and a guest OS, you have a container engine, so which directly gives you an access to libraries and apps. Okay, so so it will be more sleeker and efficient. And Kubernetes, uh, uh, sorry, Docker can run. Sorry, one second. A container, so Docker, a container is running one daemon per host OS. Okay, so you can run multiple Dockers on a single machine or on multiple machines also. But when you want to have an application, when a same application on multiple machines, and you want to have an orchestration between that, so that you can use the infrastructure more efficiently with these containers, so you go with the Kubernetes. And there are multiple advantages going with only having multiple containers and synergizing with Kubernetes. That is, various examples were given, and you can just search them up. So I don't want to stress much on these things, which are readily available. Okay. So again, this gives an a overview of what is the difference between a VM, Docker, and a Kubernetes. Okay, so think of this way: Kubernetes is just an maestro of Docker who can symphonize different instruments. Now you have various containerized benefits, because why you have to your application rather running on a bare metal, if you are using your containerized images, you have consistent environments, so that is, and simplified deployment, so which is something working on my machine, it can directly be deployed onto you, you will not have any headache. The scaling can be done, so the same Docker machine can be like, where there are multiple requests that are coming from the user, so I need not to worry about, I can just pull the image onto a different machine and horizontally scale it up. Resource management is very much helpful, because you have these Kubernetes that provide efficient resource allocation, and it can allocate CPU, GPU, and also memory resources. And uh, sometimes images like these containers, units can come with their own libraries, their own version of libraries, because sometimes say one application has to be run, I usually face a problem, because that is dependent on a particular version of TensorFlow, and that particular version of TensorFlow is dependent upon a particular version of CUDA, and that particular version of CUDA and TensorFlow needs a particular version of CUDNN. So these kind of crazy combinations, And sometimes when these are working out, suddenly scikit-learn will give scikit-learn or numpy will say I cannot work out with this version. So those kind of thing will not be a issue. Reproducibility, because you have a version control as you're having, because in the imaging this Docker images also you can have version control. So Docker version 1, Docker version 2, Docker version 3. So for the same image, okay, image version 1, image version 2, image 2. So you can have version control and dependency management, and they're very lightweight and simplified management. The learning curve is very steep for containers and Kubernetes. The starting point will be a bit difficult because it's the first time you're facing it. But once you start seeing it, you will love it. Because previously I was whenever I want to use Python, I used to install Conda, Anaconda, or something like that. I create a virtual environment and I used to have my different applications on different virtual environments. I thought that was good, great. But once I got introduced to the containers, like particularly Docker-based containerizations, I literally loved it because half of my issues have gone right away. Because when I'm giving my server to various students or various people, they started to install their own versions of various libraries, and that used to corrupt a previously running program. So rather do that, when I have instructed them to use the containers, Docker-based images, so every student has his or her version of container, and they can run their applications. Like it might be training, it might be inferencing, it might be testing, it might be deployment. Even you can do an servlets on it also, servings and anything. So cloud-based solutions. So that made my life easier to manage things, and even other students synergy has improved because one person installing a library didn't disturb the other person's code. So using the Docker for AI, so building Docker images for AI models, like even now you can have this whenever, as I said, you can do a servings on top of it. So this can have TensorFlow servings, Python, like they can pack it together, your TensorFlow, PyTorch, scikit-learn. So whatever the libraries that can be packed. So whenever you want to have a deployment on that, you can also deploy services. It's not only for training certain models, it can also use it for the deploying. So you can also do a GPU management, and also there is a Kubeflow, which is a machine learning toolkit for Kubernetes. Now, scaling strategies, it is an horizontal scaling, auto scaling are there, but horizontal scaling is most widely employed so that you can increase the throughput and available, because whenever you have an available space in the cloud, you can benefit from it. Okay. Now coming to the deployment part of it. So there is one thing, as whatever the previous strategies we have taken up, all those strategies will work out for both training and inferencing also. Okay. But there are certain techniques that will be more help you for deployment. That is, you have already trained a model, your model is ready, but you have that model has to go through certain makeup before being placed into the hands of the user. Okay. So one of the techniques is pruning. The second technique is quantization. The third is knowledge distillation. Actually, the fourth one is low rank optimization, low rank matrix thing. Okay. So what is pruning? So you trained your model. You trained your model. Okay, good. But when you look at your model, you observe that many of the weights of those models are zeros or close to zero. Okay. And anyone who have gone through neural network lecture last day before yesterday, it will be evident that a neuron output is y hat is equal to wx plus b. That is weighted summation of inputs plus bias. If a weight is 0 or close to 0, the contribution of that particular wx will be low. So there is no point of computing an input into, that is x into w, when the weight is 0 or close to 0. So what this methodology does is, wherever the weights are closer to 0 or equal to 0, they clip them off, or they will not use it while computations, and use only higher values of weights. When I mean higher values of weight, it may be a negative higher value or a positive higher value. Okay. So I use only those weights which are of higher values and use this model. And one more beauty is these sparse matrix computations are supported by CUDA GPU and other manufacturers. So even though you're making a many weights as zeros, that becomes like a sparse matrix or a sparse vector. So your computations, it's not going to hamper your output because zero has no contribution in the output. At the same time, you're reducing the number of computations because you are not considering those weights which are equal closer to zero. So that is termed as pruning. So when you do the pruning, you let go of the weights which are not contributing. The second one is the quantization. So quantization is when you're training your model, as the weights need to be upgraded or updated with your gradients. So, and usually gradients will be of smaller values so that a certain precision need to be maintained while training, because your weight can be like, your gradient can be 0.0001 also. Because if you look at your learning rates, they can go from 1 e power minus 3 to 1 e power minus 9 also. So you have to have certain small precision and resolution while training, but such level of precision, because the finally you don't care about gradients or anything. Once the training is done, you're only interested in the weights. So what you can do is you can do the quantization on the weights so that you can reduce a 32-bit weight to an 32-bit floating weight to a 8-bit integer or a 4-bit integer. So that is what is making the current generation, like whenever they say large language models. So large language models, particularly in Hugging Face, if you go and see, you get to see that a model will be trained on a 32-bit or a 16-bit, but the final model which they are giving to your hand is not even float. It is an integer, 8-bit integer or a 4-bit integer. So model size will be reduced. So for just for the inferencing, you can run those models on your laptop or in your computer. So that became a possibility because after post training, the weights have been quantized to 8 bits or 4 bits, not even still in float, but they are into integers. So a 32-bit, 16-bit float to 8-bit, 4-bit integers. So that reduces the weight demand, like the space taken by individual parameter weight. So deploy onto your you can bring it to your laptops or any edge device, and as it is multiplications and everything is happening in integers, so it will not be a computationally burden. Okay, and this is one of the most interesting and most widely used approach, that is student teacher approach or teacher student approach. So in the top is the model which you have trained, okay, a large model, but you cannot fit it onto a smaller devices. So what you can do is you can have another small model, and you say that if I give a particular output of sorry particular input, I know this model is supposed to predict a certain output. Okay, and I will train my student model also. Whenever I give this input, the output of the student should match with the output of the teacher. Okay, so by doing so, the student will be mimicking the teacher for a particular data set. So it will be learning the knowledge that is needed for this particular data. Okay, so this way, even though I initially trained a larger model, so finally when I want to deploy it, I'll be using it as smaller model. You might think, okay, will it work out is the question. Because yes, you have to compromise on accuracy to some extent. You have to trade off, because there is no freelance theory. As per no freelance theory, then thing comes for free. So when you're compromising on your parameters, you are how to trade off with the accuracy, maybe, but not to the extent with the reduction, because the number of parameters are reducing are very high. So the loss compromise of 1% or a 0.5% doesn't make a much of a difference. So this is a student teacher approach. So one derived part of this is what was used by Meta, Facebook. Since the last session also, I pointed out towards one thing, that is initially Meta, that is WhatsApp, came with Llama 3.1. Okay, Llama 3.1 has lots of parameters, and to reduce their cost, they've introduced something Llama 3.2, which is a 1 billion parameter and 3 billion parameter model. So they actually did a knowledge distillation. So here it is like Llama 3.1, and the teacher is like Llama 3.1, and the student is like Llama 3.2 architecture. But I'm not speaking about Llama 3.2 vision. Okay, I'm speaking about only Llama 3.2, which is being executed on your mobile phones. Of course, it needs cloud, but they shifted from Llama 3.1 to 3.2. So this is the way how the knowledge distillation can be done from a large model to a smaller model, and it can be deployed onto various devices. And finally, it is the low rank factorization. So where usually whenever you have an set of layers, and where each layer is populated with different neurons. So these neurons, when you are doing a multiplication, that is actually a matrix multiplication. And when you perform a singular value decomposition on these particular matrix, and you can have a low rank factorizations, so you can reduce the number of multiplications, like computational intensities. So this way, you can reduce the, because straight away, like after the post training, this is one way to do it. And along with these various optimizations that you do from your developer point of view and AI point of view, or AI architect point of view, there are also certain optimization techniques or optimization services that are being provided by the cloud providers. Okay, so for the most popular cloud providers are AWS, GCP, and Azure. Okay, everyone got their own various services, custom services, and also generic services. That is, some services which are available in AWS also available in Azure, and also available on GCP, Google Cloud Platform. But there are certain services which are only custom for AWS, something like Amazon S3. Okay. So because you want to have a storage optimization of the S3 buckets, so that is where Amazon comes into play. S3 will come into play. And AWS Spot instances, AWS Lambda, AWS SageMaker, particularly for machine learning and utilizing, because this is very much basically training and deployment of machine learning. Many people use this Amazon SageMaker. And automated model tuning, it uses an hyperparameter optimizations to enhance the model performance and stuff. And it also has AWS deep learning AMIs. So it has a pre-built environments with your TensorFlow, PyTorch frameworks, deep learning frameworks. So you not to worry about the compatibility between your TensorFlow version, CUDA version, and CNN version kind of things. So you can also have consulting partners and expert guidance also. And in coming to the Azure optimization for AI, so Azure has a machine learning thing, which is an end-to-end ML framework. And as it is Amazon, so Microsoft is working on certainly different, like unlike it doesn't have something like TensorFlow, because TensorFlow is from Google, and PyTorch is from this Facebook. So similarly, I don't think Microsoft has something specifically for deep learning, but it got very good frameworks for various other things like agents, racks, and graph, particularly graph knowledge graphs and stuff. They have very good platforms, their own custom-made services, and Azure OpenAI services, Azure Cognitive Services, Azure N Service. So there are like various services that are which are custom for your Microsoft Cloud. And many a times, maybe there will be certain models based upon which you want to fine tune the things. So Azure also has a AI model catalog. So you can have a foundational models so that you can use them, and you can go use them and straight away, right away. Now coming to AWS, I'm not pretty sure if such model catalog is available. But one thing is, NVIDIA Cloud NVIDIA also has certain these model catalogs. So NVIDIA is straight away giving, and you can pull those models through NVIDIA into AWS. So there are always a way around for certain functionalities, even though that particular platform, that is the beauty of cloud. So, and also as it is supported with larger bandwidth and stuff, you not to worry about what will, okay, if I want to download a 100 GB model, how much time does it take? No, it copies like lightning fast. And also you have certain services for Azure AI Vision and Speech. Amazon also has certain services. Maybe it was not listed previously, but AWS also has certain services. And cost optimization features from Azure. And GCP, it's Vertex AI. So people who are using Gemini, particularly Gemini API, will be knowing this, because whenever you are supposed to use a Gemini API, I personally prefer API based chatting or development, because I can plug it into my Python program and I can use it straight away as per my convenience, rather always typing something to get a response. At that point of time, you are supposed to have an account on GCP, and through Vertex AI, you can have an account and you will get an API for your Gemini. So Gemini Flash 1.5 is free at this point of time. And also Gemini 2, which is an experimental version, can also be accessed through this API. I think 1 million tokens will be costing low, even in its plus like pro mode. But yeah, currently I use majorly for that reason, this thing. And Google Kubernetes engine, as I'm saying, Kubernetes and containers also supported on Azure and stuff, okay, and not only in GCP. So there are BigQuery, cloud TPUs, because TPUs are coming to the picture, because tensor processing units are designed by Google. So TPUs are specifically for them, and you have various other service specific optimization techniques or optimized services also. Okay. So in conclusion, we have seen how AI growth in data, like AI needs in data being hungry, and AI models being larger number of parameters, are needing demands for larger clouds, cloud storage, like demands for cloud storages on cloud services and cloud computations. And when you want to do a cloud computations or cloud optimizations, you can have two verticals of it, two ways of approaching it. One, for as an AI architect, how can you optimize it? And as a developer, once provided an instance, how can you optimize it? Or when you are provided an instance, how can you do an optimization better? So why I have stressed more on the second part? Because so that optimization techniques, what you're considering for given instance, can be extended for your premise compute also. So you have you are a very good institute which you have your own HPC per se, or your institute has a collaboration with with some of the IITs which has Param Shakti and everything, which can give an access to them. So at that point of time, how can you leverage the given access? Because they might be giving you access, but as a developer, you're supposed to make use of that given resources effectively. So the second part of optimizing the AI workloads was stressed more. And finally, after training your model, due to with the data parallelization, model parallelization, mixed precision, batch optimization. So with all these things, you have trained your model, but end of the day you have to deploy that model. So when you're supposed to deploy the model, you are supposed to do certain post processing on the model, so that the computation burden of the model during inferencing will be reduced. So one thing which you have taken is the quantization part, pruning part, knowledge distillation. Okay. And also we have also taken certain practices using containers and Kubernetes. So as a developer, it is very much needed to maintain a neat, clean environment of your development. Okay. So these practices collectively will impact your resource management on AI, yeah, your AI resource management on your cloud, which is supporting your AI, and also in your day-to-day career also. So with this, I think my content is done. I have nothing more to share in this context, unless you people have any certain questions.
Hi, sir. This is Ramesh.
Hi.
Am I audible?
Hey. Yeah, you're audible.
From the developer perspective, when it comes to GPU optimization,
Mm-hmm.
is there any necessity to learn parallel processing algorithms? I mean, parallel processing libraries like Dask or Apache Spark? Is there any need to learn those libraries when it comes to GPU optimization from the developer perspective?
Okay. So when you are, if you are using those libraries as part of your training process, you are supposed to learn them. No doubt about it. But say you are not even at this point of time, you're not scaling at that part of to that point. You are doing only at the premise level. Then you need not to know do it.
Oh, okay, sir. I have another question with respect to the DevOps and MLOps. How these are
Mhm.
different when it comes to software engineering and data science? So, what is the difference between MLOps and DevOps? Maybe it is too naive, but maybe it is out of context. I wanted to know from your point of view, what is the difference between MLOps and DevOps?
Uh, and I can speak more on MLOps because recently that is very much popularly speaken up thing, right? So I can say that both are like software development strategies only, aim for improve the efficiency. But to my understanding, DevOps focuses on the software development life cycle, but MLOps focuses on the machine learning driven solutions. Okay, so DevOps is more generic in nature, but MLOps, like as machine learning is coming to the picture, so you want to run that, you want to have the this product life cycle more effectively and efficiently. So as machine learning is coming to the picture, so your ML, you can say MLOps is like subset of DevOps, but you have more skill set on how to maintain these machine learning models and improve the machine learning models.
Oh, thank you, sir. Thank you so much.
Any queries still? If no queries, then we can wind up our schedule.
Sir, David,
Thank-
sir, David, sir,
please.
can you look
Please.
into chart once? Group chart once. Hello, David, sir, can you please look into chart
Yes,
once?
Sir, here is a question.
Yeah.
While running CNN and transformer models together in Google Colab, it is showing that convert it into GPU. How can we convert it into GPU in Colab, sir?
Sir, if that error message was given, that will be makes more sense. But to my understanding, when they mean convert to GPU, the input what you are giving, like your model might be on GPU, but the data might be still on your CPU. That could be one reason, because unless I see the code and unless I see the error, complete error,
Okay.
I cannot answer. But to my understanding, from where I can interpret, that is when you want to process a particular data on a particular model, then both the model and data should be on CPU, or both the model and GPU, model and data should be on GPU. So usually the
Okay.
common mistake is you can push your model to GPU, but when people load the model, load the data from the database or from the local file, they might forget to convert into load into GPU.
Okay, sir. Yes, sir. I understood, sir. Madam, is it clear? Okay. Thank you so much, sir. Fine, sir. For your wonderful session. We understand almost live applications, live examples you have given. We can optimize from what we can say processor to the batches and all those things. Thank you so much, sir, for your wonderful presentation. Thank you
Thank
all
you,
the
sir.
participants. Let us meet tomorrow. Let us wind up our session. Thank you so much, sir.
Thank you, sir. Thank you very
Thank
much.
you all
Thank
the
you.
participants.
Thank you, participants, for being the patient, by being very patient and listening. And thank you,
Yes, sir.
David Garu, for inviting me and giving an opportunity to be part of these wonderful sessions. Thank you.
Feel pleasure, sir. Thank you.